We're looking at exponential growth and decay models today. When you've got a real life quantity and it increases or decreases by a fixed percent, it can be modeled by one of these two equations here. So we've got y equals a times 1 plus r to the power t, or y equals a times 1 minus r to the power t. The first one, of course, is growth because you're adding something. The second one is decay because you're subtracting. In order to use any kind of formula, we have to know what each of the variables stand for. So A is your initial value, your starting amount. R is the rate of growth or decay, which is in decimal. T is the time, which can be measured in any increment you need. And Y is not on the list for some reason. Y is your resulting amount or resulting value. You'll also see some other terminology within the work today. The growth factor. If they ask you for the growth factor, that's 1 plus r, and the decay factor is 1 minus r. Okay, real quick reminder about r. R is the rate of growth or decay, and it is in decimal. It has to be in decimal within these formulas. Usually within the problems, though, they give it to you as a percentage. So if we had something like 27%, when I change that to decimal, that would be 0.27. So if I bring that down to my growth factor here, my growth factor then would be 1 plus 0.27. So that would be 1.27. And the decay factor would be 1 minus 0.27. So that would be 0.73. Alrighty, so now we'll get into our first example here. These are word problems, of course. Your first step for working with a word problem is to read it. So we've got in 1998, there were 29.67 million internet hosts. During the next 7 years, the number of hosts increased by about 39% each year. First thing they want us to do is write an exponential growth model. When they're asking you to write the model, you still have to have two variables for that. So my two variables are going to be y, which would be the resulting amount, and t, which is the time. Those are the two things that can vary and affect one another. So first things first, within the problem, they tell me that time, the starting time, time t equals 0, is 1998. So that's going to be an important thing to notate there. It also tells me that that this problem is only good for the next 7 years after that. So this model that I'm going to write is not valid for any t values that are outside of this domain here. So I want to go ahead and notate that as well. That's not always a necessity, but the way that this problem is worded, we do actually have to say that there. Okay, so now I'm ready to write my model. I'll say y equals, and they tell me that there are 29.67 million internet hosts at that starting time. So I'm going to put that in 29.67. And then it's increasing by about 39% per year. So since it's increasing, it would be 1 plus, and then 39% I would put in as 0.39 to the power t. Okay, now because 1 plus 0.39 is pretty easy to calculate, I think I would go ahead and calculate it. So I'm going to say 1.39 to the power t. This is my model. So for this first one, that's all they were asking me to do. All right, now they're going to ask me some questions. So for this next one, it says, how many hosts were there in 2003? So they're giving me a time, but they're not giving it to me directly. So I have to do a little bit of work to figure out what the t value is for that. Since t equals 0 is 1998, then to figure out my t value here, I'd have to take the year that they give me and subtract 1998. And so that would give me 5. So what I'm doing now is I'm just putting in 5 in place of t in the model that we wrote in the first part. I'm going to use that simplified 1.39 instead of 1 plus 0.39. And I'm putting 5 in for t. Okay, so now I have to type this into a calculator. The calculator that I used, normally, of course, we would use our Inspires in the classroom, but we don't have that as an option today. So the calculator that I used, I just did a Google search for a scientific calculator, and they gave me a pretty nice one there. Now, if you're going to effectively use this and be able to do your practice problems here, and perhaps even use this information later in your life, um, you need to know how to work a calculator like that. So at this point, it would be a pretty good idea to pause the video, go pull up that calculator, and do this calculation to see what I have as the answer. And then if if you get the same answer that I did, then you can move on. All right, so the answer that I got was 153.954. My Ys in this one were measured in millions of internet hosts, so this would really be 153 million, 153.9, so almost 154 million internet hosts. Alrighty. Okay, so now we have one more question. The next question is estimate the year when there were about 80 million hosts. Now, once again, if we had our graphing calculators, oh no. If we had our graphing calculators handy, I could show you how to do this pretty easily, but we don't. So we're going to do this by kind of a guess and check method. Okay, so I'm going to take a guess. I'm going to say I think it's probably pretty close to 3. I don't even know what's going on with my pen here today. It is just not cooperating. And now I can't even I can't even erase stuff. There. Okay. Let me try this again. All right. So we're going to guess about 3. And I'm going to make some notes while I'm doing this. Let's try a text box. Okay. So I'm guessing 3. I'm going to input that into my my model that we wrote up at the top there. And when I do that, I get 79.68, which is pretty close. But I want to estimate this to the nearest tenth of a year. It doesn't actually say it there. I meant to include it, but I didn't. So I'm just telling you. So I'm going to try now 3.1 because 79.68 is a little bit small. I wanted 80. So let's see if 3.1 is a better estimate. Put that in my calculator. I get 82.35. So that's a little high. So 3.1 is too much. So I think what I would try next is maybe splitting the difference between them. So exactly halfway between 3 and 3.1 would be 3.05. So if I put that into my equation, it gives me 81.01. So of these three here, if I'm going to be estimating to the nearest tenth, I know it has to be somewhere between 3 and 3.1, because those were my boundaries there, 79.68 and 82.35. I did 3.05 exactly halfway between, so I could see if 3.1 was closer or if 3 was closer. And with that information, I can see that actually 3 years is the closest one we've got there. So I would say 3 years is my answer. Okay, now you try the next couple of questions on the Google form.